Hello and welcome everyone who's joining us in person on this beautiful and partly sunny day in Seattle. And to everyone online as well, from wherever you are, I hope you're having a great day. I guess if you're coming to this session that YAML is probably not your favorite thing. I do have an admission though. We will be seeing some YAML today. However, we'll be skipping writing most of it. I'm Ahmed. I'm a product manager on the Azure Kubernetes experiences team, and I'm joined by Quentin.
Hey everyone, I'm Quentin. I'm also a product manager on the AKS team. Also, just a heads up, we will be asking a question to you folks about the presentation at the end, and the person who answers correctly will get a signed book, the Kubernetes Best Practices by Brendan Burns, so do pay attention. So developing apps on Kubernetes, takes some considerations, right? Like we obviously would love to just magically deploy things, but that's not really how it works, right? You got to build the app to a container. You got to figure out, how to deploy it to your cluster. You got to write YAML, and then eventually, you have to do some observability and troubleshooting. So in this session, we're going to focus on how to develop, package, and deploy apps to a cluster. And we're also going to talk about observability and troubleshooting. Now, we will hit all these other sections as well, but these are the two ones we're going to focus on. Now, we do recommend watching Breakout 181 and Breakout 193 if you really want to have a bigger deep dive into observability and troubleshooting, or if you want to deep dive into cost analysis, optimization, and scaling applications. So, Ahmed, how can we develop, build, and deploy apps onto AKS?
So when it comes to deploying apps on AKS, the first thing would be to deploy the app on a cluster. But when it comes to creating a cluster, there's a dizzying array of knobs and configuration options that frequently overwhelm those who are just getting started. So for that reason, we created AKS Automatic to address that. And automatic clusters come pre-configured with all of the best practices for networking, for compute, and security that can help you land on a good, successful path. And they also have safeguards in place that can prevent, and in some cases even solve, many of the common workload issues and configuration problems that can result in reliability or security issues. And speaking to one of those configurations, it is the ability to run the cluster's API server, which the nodes and every node in the API in the cluster communicate with, in the same virtual network as the cluster itself, and thus allowing the nodes to communicate privately to the cluster without leaving the network, and as such providing a more secure environment. And we're excited to announce today that the API VNet integration feature is now generally available and as part of AKS Automatic and as part of AKS Standard as well. So to get started, let's see what we'll do now. So what we're doing is we are a thriving airline startup, if there's such a thing, that has a new flight booking system online and a trip booking system online. It's a Node.js application, and I'm just a dev. I'm writing the app. I'm going to be writing the app. I have no idea about containers and containerization, and that's something that I really want to start learning about. So the app itself, at a high level, is a bunch of diagrams. So we have a lot of components, a lot of things that we need to figure out today. The app itself, the source code of that app is on GitHub. Contoso Air uses GitHub Actions and GitHub, the environment of GitHub in general, to write and deploy their code. We're going to be pushing that code and building that code into a container registry. And that these container images are going to be running on an AKS Automatic cluster. We want to expose that application to the internet for our customers to use over Contoso's domain name with Contoso's SSL certificate. And the app also has a functionality that we want to use AI for, of course. And that is a recommendations engine that uses the Azure OpenAI API. So we want to build something to use that. And finally, we also want to instrument the application and enable monitoring to see and observe how the app runs and performs. So there's a lot of things here to do, and it's a bit overwhelming. I don't know where to start, but I do know that I can start from GitHub, and I can start from where my code is right now. So the app itself, the source code is it's stored on GitHub. And the first thing I'll do is I'm going to open GitHub code space with that code repository to see what the repository looks like. There's no Docker file here, so I'm going to be using GitHub Copilot and asking it to create a Docker file. And that is needed to containerize the application. So what GitHub Copilot would do is that it will look at the repository and the repository structure. It figures out that that's a Node.js and a React app. There's a bunch of packages in there. It knows that to build that application, it needs to run npm install. So it creates the Docker file, and the Docker file looks great. It uses the latest stable Node.js version. And now I can actually build that Docker file right within the GitHub Codespaces environment, just to give me an idea and a validation that that thing works. And I'm also going to run it within the GitHub Codespaces environment and see how it looks like. So once that is deployed, I can actually launch that application straight from within GitHub. And that is the button that we need to implement the functionality for. So we'll go back to our code repo in Codespaces. There's a placeholder function or a placeholder service for the recommendations in the backend, which is called the recommendation service. It has a couple of placeholders for the functionality we need to do. The first one is acquiring an access token to communicate to the Azure OpenAI service with workload identity. We also want to generate embeddings, and we want to get recommendations based on what the customer or what the user asks us. So I'm going to ask GitHub Copilot to fill in the missing code. And I'm also going to provide some instructions on the names of the environment variables to use, because that is something that I'll need to configure later on to configure the authentication from Azure. So GitHub Copilot is going to iterate a couple of times over this code to generate the code. And obviously, it doesn't always work from the first time. So even if it creates something that doesn't work, I can easily feed that error back into the chat interface and then keep iterating on that until I have something that works for me. Looks that this is good. I'm actually now going to commit that code back into the repo so that we have the Docker file in place and we have the recommendation service source code in place as well to deploy. Now, Quentin, you are my DevOps engineer here. How can I actually get this application source code from GitHub to be running on a cluster? Can you show us that? Or actually, before that, let me jump back into some of the code that was actually generated. So as I mentioned, the application uses workload identity to communicate to Azure OpenAI. I could have used a connection string. I could have used an API key. But the most secure way now to authenticate to Azure services, a variety of Azure services, is using workload identity with managed identity through Entra. So since this is a Node.js app, the package or the SDK to use that is the Azure Identity SDK. And it's using the default Azure credentials. And that needs a couple of environment variables that I need to pass into the application once I deploy it, that essentially tell the workload identity SDK or the Microsoft Authentication Library here how or which identity it should use to actually acquire that access token. So that's the first bit of code that Copilot generated for us. Moving on, the next one was the API calls to Azure OpenAI. So the way recommendations work is through something called embeddings. And for those of you who are not familiar with what that is, I certainly wasn't until I actually built that demo. What it does is that when you provide an input, let's say you provide a text input like, I want to go somewhere to ski. So that's a textual sentence. What an embedding is that it generates like a vector representation of an array representation of what all of these words and just have like mean next to each other. And then that is stored in a database somewhere for comparison. So this is the method, or this is the function that actually generates this embedding by calling the Azure OpenAI embeddings endpoint and providing the input text and passing in the access token in the authorization header. The final bit of code is getting the embeddings for the user input, so a text field that the user entered in, something like I want to go ski, and then comparing that with what we have in the database. In the demo app that we have here, the database is a simple JSON file with a lot of attributes. So there's a description of a city, there's the country, what's the best time to visit, what are the activities to do in there. So there's a lot of attributes that we can just add together into one long string, which is then the description in there. And that is the thing that we generate the embeddings for. And finally, the recommendation itself comes from comparing the embedding that was generated for the user input with the embeddings that are in our database and selecting the one with the best score or the highest score. And thus essentially picking the one that has the highest match or highest probability match with what the user is trying to do. So with that, now, Quentin, can you help us get this deployed, please?
Yeah, for sure. So beyond the cluster configuration of packaging an application for deployment on Kubernetes involves, again, containerization, which Ahmed did, and then writing a bunch of those YAML files. So the automated deployments feature on AKS makes this real easy. It can take your application from source, so from a GitHub or Azure DevOps repository, and generate a Docker file and a set of Kubernetes manifest files that will run the app in a scalable, reliable, and secure configuration with AKS best practices. So this is all built on an open source templating engine that we call Draft. And it also creates GitHub action workflows and Azure DevOps pipelines that build your code into a container image and then deploy it to your cluster. So let's see this in action, and let's take Ahmed's application and get it deployed. So in the portal, we'll go to the automated deployments blade. And the first thing we're going to do is give our workflow a name. So this is going to be the name of the pipeline. We choose GitHub because GitHub is where our code's at. And then we're going to just make sure we pick the appropriate repository and branch. In the application tab, we have our own Docker file, so we'll select it. But again, if we didn't, automated deployments could create one for us, given the code in our repository. We'll make sure to create a new container image called 𝗏𝗏𝗀𝗏. And then we're going to generate those Kubernetes manifest files for deployment. So again, they have all the best practices baked in for us. After that, we'll make sure the application port matches, and we're going to create a new namespace called 𝗏𝗏𝗀𝗏 to actually deploy our app into. So if we rewind a bit, we saw that Ahmed used GitHub Copilot to quickly add those kind of AI capabilities to the app. So now what we need to do is actually connect that to Azure OpenAI to kind of make our app AI-enabled, right? But traditionally, you would still need to manually configure all those connection settings to integrate with Azure services, and that would also be done in the YAML and so on, and it gets a little messy and complicated. So this is where automated deployments and Service Connector come in. So Service Connector helps automate the setup of things like workload identity, federated credentials, role assignments, firewall rules, and other connection configurations. It supports over 30 Azure services, including databases, caches, and more. And it makes it very easy to securely connect your AKS apps without that manual overhead. So let's go back to automated deployments and use Service Connector. So we can use Service Connector by just pressing Create a Connection. And then we just type into the service that we want to connect to. So it's easy as doing that. We type in OpenAI. Everything's pre-filled for us. We make sure we pick the right managed identity for our application. And then if you actually look into the advanced settings here, we can see those environment variables that Ahmed coded into his app. After that, we just go and press Review and Create. And then once automated deployments actually kicks off the application for deployment, all of this is handled in the back end, and our app should be connected to Azure OpenAI. So the OpenAI and the AI enablement pieces out of the way, now we need to make sure that our app scales properly. So AKS has a couple of built-in scaling add-ons to help offload the operational complexity of managing pods and services and scaling those out. And so here are a couple of them. The first is HPA, which stands for Horizontal Pod Autoscaler. It adjusts pod replicas based on CPU, memory, or custom metrics. It's the most common and easiest way to scale your apps in Kubernetes, and it's recommended for most workloads. We then have a Vertical Pod Autoscaler, VPA. It adjusts CPU, memory limits, and restarts pods with optimized settings, and it's now available as a managed add-on. And then finally, we have 𝗬𝗲, which is the Kubernetes event-driven autoscaler. 𝗬𝗲 extends HPA to scale based on event sources, so you can think of things like queues and so on. It works really well with Azure services like Azure Service Bus. And this is also another managed GA add-on on AKS. So if we go back to automated deployments, we can click the application configuration change button. And we'll see some of the resources that are going to be created in our YAML file right here. And we do get to change them, right? So we see some CPU limits, memory limits, health checks, and the scale method, which is set to HPA. So scaling out of the way as well, the next thing is we want to make sure that this application is accessible to users on the intranet. So to do that, we'll use the application routing add-on in AKS. This provides a managed Nginx ingress controller that automatically handles routing external traffic into the cluster. So it automatically sets up DNS records via Azure DNS based on our ingress rules. It lets us attach SSL certificates from Azure Key Vault for secure HTTPS traffic. And all of this removes a lot of the manual effort involved in setting up the ingress, DNS, TLS, and so on. So we can really just focus on the app and less on the infrastructure. So to do this in automated deployments, we click Expose Ingress, and then you can see that Nginx ingress controller that was created for us. And then what we can do is just kind of fill in the blanks. So we need to pick the appropriate certificate for our app, so we'll pick the Key Vault and pick the certificate. After that, we'll make sure that we pick the correct Azure DNS zone as well. And then we're going to give ourselves a subdomain name called AIR for our application. After that, automated deployments is pretty much good to go. We have an option to add some environment variables if we need to, but we don't really need to do that. So we can go and we can click Next and get ready to deploy. So behind the scenes here, automated deployments is actually spinning up a pull request to a repository with all the files needed. So that's the GitHub action, workflow. Those are the deployment, the service, the ingress, et cetera. It looks like it just finished, so we can go and actually approve that pull request now. So again, if you want to make any changes to the YAML files, you could, or you could just kind of skip it. But as you see in our deployment, we have some of those best practices. You see the liveness probes, the readiness probes. You even see some pod security standards that we'll get into a little bit later. And then you see, our HPA, right, our ingress, right? This is all YAML that you didn't have to create, and it was created for you with those AKS best practices built in. So if we press merge now, we'll actually kick off those GitHub action workflows, and we can do that and take a look. So if we go to actions, we should see the workflows kick off, and we see we have two right here. One, building the image, and then two, actually deploying the app. Now these do take a couple minutes on the first deploy, but after that, they do speed up quite a bit. And it looks like it's done. So if we actually go back to the portal and go to ingresses, we're going to see that URL that was created from app routing. So we see it right here. We can copy it and go into a new browser to check out to make sure our app was deployed properly. And as you can see, the application's up and running. And we have that Inspire Me button. That was that AI enablement that we wanted to get done. And Service Connector did that for us. So if we say, hey, we want to go somewhere sunny and warm, it should give us a suggestion, and it wants to send us to Cancun, which sounds pretty good to me. So just to recap, we released a bunch of new features that build for automated deployments. The first being Azure DevOps integration, right? We know folks use Azure DevOps, and they want to connect to their Azure repositories and create Azure pipelines. So we support that now. We added a bunch of new support and best practices to our generated templates, so things like support for ingresses with DNS and Key Vault. We've added service connector, allowing you to do, really, deploy full stack apps, just like what you saw with that application connected to Azure OpenAI. And then we also have in preview support for AKS Fleet Manager. So now you can create deployments targeting hundreds of members of a cluster in a fleet. We're also announcing the public preview of the recommended services blade. So these recommendations for other Azure services to use are based on your Azure subscription and your cluster profile. And it's really great, and it's available in the portal right now. So Ahmed, this was pretty easy. We got the app up and running, but now I feel like we have to get to that next step, right? Like, what do we do once the app's deployed? I feel like we have to, troubleshoot, monitoring, observability, things like that, right?
Yeah, I'd say, Quentin, this maybe looked too easy as well, that I'm a bit worried that things might break. So for observability and troubleshooting, so Azure Monitor provides an end-to-end application monitoring stack because when developing and deploying apps in a cloud-native world, there are lots of moving parts that could break, and potentially you might need to monitor and observe to make sure that they're acting properly. And our goal is to meet you where you are. So you can use all of these components together. You can use part of them, some of them. Today, since we're focused on the application monitoring or on the application development, essentially, I'll focus a bit on the layer of application monitoring and see what each of these services look like and how they can work together to help us today. So the first one is the Azure Monitor Managed Service for Prometheus. And that is a fully managed and highly scalable version of Prometheus. And with that, you can have all of the benefits of Prometheus, such as managing the metrics, collection of the metrics, without having to worry about installation and managing and operating Prometheus yourself, since it's a fully managed engine. And for collection of logs, we have Container Insights. So with Container Insights, we can collect logs from the cluster. We can also collect additional metrics that can support or complete the monitoring that Prometheus provides for us. And we can analyze those logs from within the Azure portal and also visualize them in the Azure portal as well. The third bit we have is the application instrumentation, which we now have in public preview. And app instrumentation or auto-instrumentation through application insights, it provides an application performance monitoring platform for web apps. It integrates with OpenTelemetry to provide a sort of a vendor-neutral approach for collecting and analyzing telemetry data. And it's in public preview today where you can collect data such as metrics, requests, and dependencies straight into application insights without having to do any changes in your code. The last part of this puzzle is visualization. And Azure Managed Grafana is a managed service for analytics and monitoring. It is supported by Grafana Enterprise and provides a really flexible and extensible data visualization platform. There are a lot of built-in dashboards that can help you monitor a lot of things that are happening in your cluster, but there's also the ability to customize this, of course, and pull data from a variety of Azure sources and also from your application too. So with that, let us proceed and see how we can add observability into the application using Prometheus and instrument that with monitoring through App Insights. So I'll head back to Code Spaces, and I'm also going to ask Copilot to instrument that application using my Contoso Air App Insights resource, which is already on Azure. So what this will do now is that it will use the Azure Copilot for Azure extension to actually query the Azure resource graph and get the instrumentation key of the application insights resource on my behalf. Once it has that, it will generate the YAML required to create this instrumentation configuration. It knows that this is a Node.js app, so it's going to set the instrumentation platform to Node.js, and it's going to add the instrumentation key that it got from my Azure subscription. For metrics, the app already exposes a metrics endpoint, and now it's just a matter of telling Prometheus how to or where to scrape those metrics from. Similarly, Prometheus has a custom resource called Service Monitor, where I can tell Prometheus that, hey, this is my endpoint for collection of metrics. Go and scrape it. So all what I did in this case is I've told Copilot to add a monitoring scraping configuration. It looked at my application. It found the monitoring endpoint, and accordingly generated also that YAML that looks at that service, 𝗦𝗲𝗀𝗃𝗀𝗃, and publishes the endpoint. Once the app is deployed again, I can now see an application map that is generated. The application map has all of the dependencies of my application. So for example, the calls to the 𝗦𝗲𝗀𝗃 OpenAI endpoint, and I can see performance, I can see errors, I can see counts of calls. And for the metrics themselves, they can also be exposed directly into the dashboard running into Grafana. So this is the Node.js process metrics, but also this is combined with cluster metrics for CPU and memory usage and workload metrics in general, so you can see like network bandwidth and requests per second and all sort of things. And in preview, which we, I think, launched maybe 2 days ago, you can also now integrate those Grafana dashboards straight into the Azure portal, so that you can have the same visualizations and the same custom dashboards without leaving or without having to leave the Azure portal from the AKS blade. So what about the app resiliency and scalability? You haven't really touched upon that. So back to you, Quentin.
So if you remember during the automated deployments demo, right, we generated those Kubernetes manifest files. I said there was kind of AKS and Kubernetes best practices built in. So this is a snippet of that, right? So this YAML snippet uses two key Kubernetes scheduling features, pod anti-affinity and topology spread constraints. Anti-affinity prefers to schedule pods on different nodes. So if one node goes down, we don't lose all the replicas. This is great for high availability. And topology spread enforces an even distribution across nodes or zones and prevents hotspots and ensures that pods aren't all packed into a few nodes. Again, supporting kind of scaling and performance balancing. So together, these really do help keep your app fault tolerant and load balanced. And in this example, we're using the node hostname as the topology key to spread across different nodes. But you could easily switch this out to availability zones if you wanted to for even greater resiliency. With those constraints in place to deploy across different nodes or different zones, we want to make sure that we don't actually have to create those manual nodes when scaling occurs, right? So node auto provision is the scaler that works on AKS Automatic. And it's really great at just, again, abstracting that infrastructure away from you. It picks the right compute to satisfy your workload resources and placement requirements. It also reduces your cost by optimizing how efficient the nodes are utilized. And it's based on the open source project called Carpenter. There's also cluster autoscaler, which is another option to scale your cluster. This is the more standard kind of cluster autoscaler that's been around in Kubernetes forever. It automatically scales, your cluster up and down and creates those nodes based on resource usage and constraints in response to pending pods. So both of these enable your cluster to scale with application demand, making it so you don't have to worry about manually creating those nodes.
So now that we have the app scaling and supposedly deployed across multiple nodes or multiple availability zones, how can I actually test this theory that my app is going to be resilient to failures? So one way to do it on Azure is called the Azure Chaos Studio. And Azure Chaos Studio is based on an open source chaos engineering platform called Chaos Mesh. And what it does is that it can force or it can inject faults into your environment. So think of it as restarting some of the pods that are in your cluster randomly, causing resource pressure, like intentionally running the cluster out of CPU or out of memory, causing network disconnects, causing file I/O errors, even affecting the cluster nodes themselves, so restarting the entire nodes or taking out availability zones. So you can really go to town with that and really mess up the cluster in ways and see how your application reacts to that, so that when or if disaster really strikes, you really have the confidence that I know that how my application performs during that, and like it can fail over, it can withstand some of these issues that happen. And it's available as a component that you can install and run on Azure. And furthermore, beyond just case testing, you can also load test your application to test the app's resiliency and scalability under load. Even integrate that with Chaos Mesh. So you can run this through CI/CD pipelines where at the end of the CI/CD pipeline, you can trigger a load test, store the results, and maybe even fail the build or fail the deployment if it doesn't satisfy a certain metric that you have. And you can also run a chaos test in conjunction with the load test so that you can see, okay, my app is crashing, or maybe I don't have all of my nodes up, but also I have all of my customers are now hitting my website, because you know that like things don't always break at the most inconvenient moment. So there's a way now to simulate that and see, okay, how does it actually work, and how can you be resilient to that? And I think like the final part that we wanted to touch upon is security of the app and best practices that we have for that.
Yeah. So we're going to rewind again back to the deployment that was created by Automated Deployments, because you may have remembered me mentioning the pod security standards as well. So by default, Automated Deployments adds a security context to the pod, which includes a setcomp profile set to runtime default. So that's a baseline security measure that limits what system calls the container can make. We also add the drop all Linux capabilities by default, which is really good. We then selectively re-add only the ones that the app actually needs to run. And so this is kind of setting us up for that kind of least privilege style of development and security. And it brings us closer to kind of pod, the baseline security standards for our pods and our application.
Just remember that you get this out of this, all of this out of the box. Like you typically would eventually add these things in, but because you're using automated deployments, out of the box, you're getting a more hardened position and a better practice built in for you.
Yeah. So outside of automated deployments, though, I think we should talk about Microsoft Defender for Cloud as well. And one of its capabilities is the Defender for Cloud CLI. So you can integrate the CLI into your CI/CD pipelines to trigger things like static analysis tools and security scanners and so on. These can block your code from being built and deployed into a container if it has vulnerabilities. And this supports a number of source control repositories, so including Azure DevOps and GitHub Actions and more. Vulnerabilities can also show up later, even after the images are already in your registry. So now in public preview, Microsoft Defender for Cloud can also scan containers running on your cluster, as well as the images that are on your container registries, and alert you if anything looks off. And if new vulnerabilities come up after the images in your repository, with gated Kubernetes deployment, Defender can block a deployment using an image that has been tagged as vulnerable from running on your cluster. So this is also in public preview. And then one more thing in public preview. The security dashboard is brand new, and it's integrated into the AKS portal experience. It's really easy. It's attached to your cluster, and it allows you to see things like vulnerable images, CVEs, security misconfigurations, and threat detection alerts, and so on. So it's really that kind of one-stop shop for everything security related in your cluster. So Ahmed, I feel like we did talk about quite a few things here, right? So develop, build, and deploy. If we recap that, we used GitHub Copilot. We created the Docker file. We, created that AI capability in our app and things like that. We then used automated deployments to actually create those manifests, right? Create the pipeline, get it deployed, attach it with app routing to get that DNS name and ingress, and so on.
The service connector part with OpenAI.
And service connector as well. So we kind of deployed a full stack app there. The observability and troubleshooting.
Yeah, and with that also instrumented the application. We are able to view metrics from the app.
And then shift left security practices, again, kind of built into those manifests that were created for us. And then as well, potentially adding on and using things like Microsoft Defender for Cloud, ensuring app resiliency as well, again, built onto the deployment manifest, kind of out-of-the-box experience, but then using other add-ons as well if we need be. And then AKS automatic kind of tying it together too with kind of scale and optimization at the cluster level, like node auto provision, right, and things like that, just straight out of the box.
So yeah, I think before we close here, we do have a question. So we do have a book that was signed by Brendan Burns for Kubernetes best practices, and it is for the first person who would answer this question. What open source engine is automated deployments built on? Draft, okay. Sir, you can come after that and I'll hand it over. Thank you. So, yeah, I mean, we have a vibrant community that we launched almost a year ago now, which is called the AKS community. We regularly post videos on YouTube with interviews with PMs and with engineers, and also talk about product features. We have the monthly roadmap that you're welcome to join, as well as the engineering blog. And some of you might have attended the labs yesterday and tomorrow. We have all of these labs also published online that you can go through. And
I will just mention one thing too, actually. If you are interested in AKS Automatic and kind of making things easier, we do have the Automatic Lab again tomorrow at 8:30 in the morning. So definitely stop by. We're going to be running through basically kind of like the demo we showed here today. And so we'd love to see you there.
All right. If you have any questions, feel free. We have some time to answer a couple of them.
Yeah, and also please do connect with us on LinkedIn. If you feel like Kubernetes could be easier, or if you have questions about Automatic, about how to get apps deployed, kind of day 2 operations as well, we want to work with you to make that easier, and we'd love to hear your thoughts.
Actually, I have a question about that. It's been 10 years. When's Kubernetes going away? It used to, right? Like, you know what I'm saying? Like, there's the waves of technology. It did its good. We learned a lot. It needs to go away.
The question for the online audience: when is Kubernetes going away? When it is fading into the background, becoming more like virtualization, becoming more like a platform? I'd like to say that it is getting there now. Like there's a lot of higher level services being built on top of Kubernetes. We are also, like, with things like what we're showing today, we're trying to hide Kubernetes so that it's just a layer of execution, where it becomes sort of like the, I like to say, I think Brendan had this analogy, it becomes like the Linux kernel, where it's just there, and then you're building on top of that, knowing that it's a stable thing that you can build on top of. So I think we're almost getting there now.
It feels very close to it. Like, it's almost like a past service that you get to change the wheels on it.
Yeah, so like you don't have to mess around with Kubernetes here, but it's still there. You can definitely kubectl apply whatever you want. You can edit things in there. It's still Kubernetes. All right. There are no other questions. We'll hang in around here for a while. If you want to talk off the mic as well, we'll be here. And thank you for joining.
Thank you.